So we had three exam reviews, and we pretty much covered everything on the first three exam. After exam three, uh, we well, basically we started chapter six in the end of exam three. So you had some part of it in exam three, and the rest of it was after the exam three. So this exam review is only for chapter six. So the first question is what is the heat absorbed by 50 gram of copper block when it is heated from 25 to 90 degrees? So you write down the information. The mass is 50. It's heated from 25 to 90. So T1 is 25, T2 is 90. And CS, that's a typo, C sub S, or specific heat capacity of copper is given. So you want the heat Q is equal to MCAT, MC delta T. So you just plug in the numbers and you find the answer as 1.3 times 10 to the third joule. Second question is asking about the delta H of formation of C2H6 given the following information. So we have a chemical equation, we have the delta H of the reaction, and we have the delta H of formation of CO2 and water in liquid state. So we need a delta H of formation of C2H6. So that was one of the way of finding the enthalpy of a reaction. So you set up the equation. Delta H of the reaction is the sum of delta H of formation of the product minus the sum of delta H of formation of reactants. Okay, so you have to multiply the coefficient, the balanced chemical equation, by the delta H of formation. So it's 4 delta H4 of CO2 plus 6 of delta H of formation of water minus the sum of the reactants. So on the reactant side we have 2C2H6, so 2 delta H of formation of C2H6 and 7 delta H of formation of O2. So O2 is in the standard state. We know that everything which is in the standard state, the delta H of formation is 0. So we cross that out. And that equal to the delta H of the reaction, and it is given as negative 3119.4 kilojoule per mole. So you plug in the numbers. You have a delta H of formation of CO2 and water. You plug those numbers in, and the first term, the sum of delta H of formation of product, is negative 3288.8 kilojoule per mole. And then on the reactant side, you only have delta H of formation of C2H6. So 2 delta H of formation of C2H6 equal that. So you plug in the numbers and you find the answer. So question number 3 doesn't need solving. You just have to know the concept. So which of the statement is true for this reaction? So we have a reaction. We have the delta H. So that DH is supposed to be delta H. So we have a delta H of the reaction, and that's a negative number. So when we have a negative delta H, it means that it's losing heat, it's releasing heat, so it's exothermic. Okay, so that should be an exothermic reaction. So the first one is not right. It's not endothermic. And in option B, it says the work is positive. So if you count the number of gas moles in this reaction, you have 1.5 mole in the reactant side and 1 mole in product side. So we have decrease in number of gas, so we have compression. So when you have compression, the delta V is negative. When you have a negative delta V, you know W is negative P delta V, right? So the work is positive. So we have a positive work and exothermic. So A is not wrong because it's not endothermic, and heat is consumed. No, heat was released. Delta E, and this D again should be delta E. Delta E is positive. So if you remember, delta E was Q plus W, right? We know the Q is negative and W is positive. Okay, even if we don't know anything, maybe we cannot answer if it's positive or negative. But if you remember, the contribution of the work term is not that much. It's mainly the Q. So if the Q is negative and work is positive, probably delta E is a negative term. But we cannot say it for sure. But definitely option B is the right answer because it is an exothermic reaction and the work is positive. Okay, so back to numbers. Question number 4. What is the Q of the reaction when 1 gram of sodium react with water according to this reaction? So we have the reaction and we have the delta H of the reaction. We have the enthalpy. But you know that when you have the enthalpy, it's per coefficient mole of each of these reactant or product. Okay, so in the balanced chemical equation, you see there is 2 sodium, so that amount of energy is per 2 moles of sodium. But the question is asking about the heat of the reaction for 1 gram of sodium. So we start with a gram. So 1 gram of sodium, we have to go to the mole so that we can use our thermochemical equation to convert mole to joule or kilojoule. So from gram, we go to the mole of sodium, and from the mole of sodium, we know that 2 moles, because it's 2 here, 2 moles of sodium release this amount of energy. Okay, so we're good with the units. We just put these numbers in the calculator, and negative 8.01 kilojoule energy is going to be released for 1 gram of sodium. Okay, so next page. Question number 5. So 10 gram bar of a metal, Ta, is heated to 99 degrees Celsius, then dropped into the cold water. So is 99 degrees Celsius T1 or T2? So it might be a little bit confusing, but when you read the whole question, you will understand that should be the T1, that's T initial. Yes, of course, it's heated up to that temperature, but it heated up to that temperature so that when we drop it into the cold water, it starts to have heat transfer with water. So our initial, in our question, the initial temperature is 99. So T1 is 99 degrees Celsius, and then we drop it into the cold water, and the final temperature is 5.1 degrees Celsius. So you know that when you have a hot object and cold object, they start to transfer the heat until both of them have the same temperature, right? And that's what happens. That's why in the final state it says the temperature of Ta and water together is 5.1. They stop doing the heat transfer because both of them have the same temperature. Okay, so T2 as the temperature of the metal and the water is 0.51, so that's the final temperature. It's asking for the heat exchange, the amount of heat, and so we also have extra information. The specific heat of the metal is given, and also the specific heat of water is given. So we don't even need the specific heat of water. Why? So in order to find the Q of the metal, we can use MCAT formula. M of the metal, mass of the metal times the specific heat of the metal times the delta T in the metal, and we have all of these information. So you plug those information there, and the heat loss in metal is negative 131.46 joule. Question number 6. For this reaction, you have the delta H of formation of calcium oxide and carbon dioxide, and we have this reaction. So what the question is asking is the standard enthalpy of formation of calcium carbonate. Okay, so again, you set up the equation. Delta H of the reaction is the sum of delta H of formation of the product minus the sum of delta H of formation of reactants. So in product side, we have delta H formation of CaO, calcium oxide, plus delta H formation of carbon dioxide, minus the delta H formation of the reactants, which is only one calcium carbonate. So that's that. And that equal to the delta H of the reaction. And I think I made a mistake here because this is not negative, it's a positive value. So I have to fix that. So it's plus 177. So that will change everything. So I'm going to fix it right now. So that's a plus 177, and this whole term is 1029.1 kilojoule, and delta H of formation is now this should be a negative because I changed the place from the equality, so that's now negative term. So we have to add these two, and I'm doing it right now. So 1029.1 plus 177.8, because both of them are negative, we add them, and so not this, but it's negative 1206.9 kilojoule per mole. So that is the delta H of formation for calcium carbonate. So that is the answer. Okay, next question number 7. Okay, so we have this reaction and it's asking for the delta H of the reaction. So again, if you set up the delta H of formation equation, so the sum of the products minus the sum of the reactants, right? So we have 2 moles of water, so 2 times delta H of formation of water in liquid form minus the reactant side. So we have 2 hydrogen, so 2 times delta H of formation of H2 in gas phase plus delta H of formation of O2 in gas phase. So we know that any element in the standard state, the delta H of formation is 0. So for hydrogen and oxygen, both of them should be 0. So what we have left is delta H of the reaction is 2 times delta H of formation of H2O in liquid phase, and that's option B. Okay, so question number 8 is Hess's law. So we should calculate the delta H of reaction of this reaction from the two we have here. Okay, so we usually go from the first element and search for it in the series of reaction and see what needs to be done to that. Okay, so the first one is 2S, and it's in our first reaction, S. It's in the product side, so we need to flip it to go to the reactant side, because in our reaction it's in the reactant side. Also, it's 1 mole here, but we need 2 moles, so we have to multiply it by 2. Then we go to oxygen. We see oxygen is in the both of the reactions. So when you have a compound that is in both reactions, you just leave it and go to the next one. In the end, they should cancel out and it should be good to go. So we don't check oxygen, just go for the last one. SO3 is in the second reaction, and it's in the product side, just like our reaction, and you have 2 moles and 2 moles, so that's good. Okay, so we don't change anything on the second reaction. So I rewrite these reactions with the necessary changes on the bottom. So I flip and multiply it by 2 for the first one, and just rewrite the second one. So to make sure that if the reaction that we need, you do add the reactions. So elements on either side of the arrow on the reactant and product side cancel out each other. So we have 2SO2 and 2SO2 on the reactant and product, so we can cancel out that. we have 2 oxygen in the first reaction and 1 oxygen in the second reaction, both of them on the reactant side, and that makes it 3 oxygen. So when you add these two, it's 2S plus 3O2 gives you 2SO3. So, and that's the reaction that we want. So if that works, you just do the same thing. The changes that you apply to the reaction, you apply to the delta H, the change in the enthalpy too, and then you add these two enthalpies to find the enthalpy of the reaction, and that's the number you get. Okay, so that's the last one in this page, and this is the last question. So again, Hess's law. So you have this equation, this chemical equation on the top, and you have these three steps, three-step chemical reaction. So what you usually do in Hess's law, start with the first one with N2O and search for it where you can find it. It's in the last one, in reaction number 3. What changes do we need to do? It's already in the reactant side, so we don't need to flip it. We need 1 mole, but we have 2 moles, so we divide it by 2, and I rewrite it on the bottom. So the first reaction I write is the third reaction in the question. So I rewrite it, I flipped it. No, I didn't flip it. You didn't need to flip it. I just divided by 2. So 1 mole of N2O gives you 1 N2 and 1/2 O2. And you do the same thing with the delta H. So delta H divided by 2. The second compound is NO2, and if you search for it, it's in reaction number 2. It's in the product side, so we have to flip it. Also, we have 2 moles where we need 1 mole, so you flip it and divide it by 2. And I rewrite it here and did the same thing with the delta H. So I divided by 2, also change the sign. It's a negative delta H, so I make it positive. And the last one is 3NO, and when you search for NO, so NO, you see it's in 2 reactions. It's both on reaction 1 and reaction 2. So when you have something like that, it's in 2 reactions, you just don't touch it, okay? And it should be good with the changes that we make. Just to make sure, you write down the equation number 1, you just write it down with no changes, and starts to add the reactions. See if you can make up the reaction that we are looking for, we are good to go. And that's what happens. So I canceled out the reactant and products, and when you add these, add what's left, you see that's the same reaction that we are looking for. So just add the delta H of the reactions of these 3 steps, and that would be the delta H of our desired reaction. So that's basically what you need to do in Hess's law. You just start looking for the compounds in the reaction that you're trying to find, the delta H, and see in how many of these reactions we can find it. If it's only in 1, you make necessary changes. If it's in the other side of the reaction, you flip it. If it has more or less moles, you just divide or multiply by the number to make enough moles, and you do the same thing with the delta H. And in the end, you just add all the reactions to make sure that you had correct changes, and if it works, then you add the delta H and you're good to go.